Okay team, round 2 of the Chauvet light bars. Let's plug it in. This one's a bit different. It hasn't got the main socket on there, so you can't loop in, loop out to power another one. Maybe they come as a set of 3. Who knows? That would be interesting. They've all died at once from the same set. But I suppose quite entirely possible, given if they're all on for the same run time. What do we got there? That's the blue light that flashes. Looks a bit scarred. We've got our DMX still. We only have the DMX, what do we got there? The master-slave output, not the input. Okay, plugging it in, and we should get all lights on as a test, and we should get those light up 88888. Then it goes to its normal operating condition. But another one completely dead. Just going to go straight for the jugular this time, since we have a possible pattern failure. We all love pattern failures. And what have we got going on inside there? This one has been opened before. That power wire has been re-soldered to. Remember the last one split into 2, but we don't split this one because there's no extra DMX, there's no daisy chain connector that needs power, so that's why that's as it is. There's some kind of liquid there. What is going on? What is going on? That's not a good sign. Is that coming out of our power supply? That wouldn't be too flash if it was. Whoa, this is old. I say that because it's all through-hole technology down in there. Unlike the last one, we have a dip. Looks like maybe a 40-pin dip microcontroller socketed along with a bunch of other stuff for driving. Yeah, we've got normal transistors for driving the LEDs. Interesting. Another couple of socketed ICs. Looks like the DMX control ICs, even though it looks like the same generation, unless the other ones had an upgrade board installed, but don't know. Perhaps we have a different fault. Maybe this type of board has its own unique failings, but let's not get ahead of ourselves. Let's get, where are we for power? Let's go with, okay, power connector's way down the end, just like the last one. Can't really get in there. Do I have to remove this board to test it? Can I be cheeky? That's alright. Maybe I can probe down in there, and I can definitely probe on the negative. Let's see what we've got going on. Don't like that heat shrink. I might just peel that off. Lovely sticky mess. Oh, there we go. I can probe into that wire there. We can tidy that up later. I've clipped up the bench supply, and we may as well just see if this thing's going to work before we go and attack our power supply. So we're going 12 volts in. Here we go. There we go. We've got 888s. Nothing lighting up. Oh, whoa, no, something lighting up. There we go. There's the colours. So, yeah, the same colour patterns as the other one, I think. Yeah, okay, so it appears to be working. We just need to get our power supply going. Same method of retention. There's a bracket going around the top of it, held on by a couple of screws. And cracking open. What have we here? Any liquid coming out of this? Oh, I don't see any liquid. Interesting. Wonder what that wet stuff was. It must have been sitting on it, not coming from it. There's no exploded caps. These caps aren't bulging. Yeah, seems to be okay in there. Maybe it's just the fuse, huh? Or maybe it's a lot worse. I need to test that main cap and see if we have a safe voltage on it. Because the fact that it didn't start up and run means that it could very well have maintained its charge 7 volts. That's much like the other one, just seems to discharge and settle down there. Let's pull this out if we can. There's silicon everywhere. Got a tug by the main cable. There we go. Please just be a dry joint. Please just be a dry joint. I don't see any dry joints. Let's check the fuse first. No. Hold that thought. We have 6 volts, or whatever was left on that. So we know the fuse is good, the bridge rectifier is good, everything up to the cap is good. Why is it not switching and creating an output? Well, we don't have a short on the output, I don't think, because my bench supply, when I hooked it up, is still connected in. So it would have drawn max current if we had a short, so there's nothing wrong on the output side of things. What's next? We have a dodgy solder joint there, but it is still attached, so won't be that. Is our switching MOSFET okay? Let's just see if we have any charge left on that cap. We can't test other stuff in circuit as long as there is. It can interfere with your readings. So we've got still got 6 volts there. Alright, let me just short that out. Don't do this with a fully charged cap at a few hundred volts. I'm just going to bridge across positive and negative and hold that for a couple of seconds, and that will drain it completely. There we go. Let's check with diode mode, and we want here's our 1.2 volt. It may be a MOSFET, it might not be. So gate, drain, gate source, or base emitter, base collector. Do we have a short that way? No, we don't. We have a reverse. It could be a body diode drop. There's a little diode stuck on the surface there. That appears to be shorted, but if it's across the primary winding, then it's not a short, it's a false alarm. What is it across? It's across a little resistor. That's like a 10 ohm, I think, by the look of that. With the naked eye, my eyes are not that good, very naked. Is our feedback opto isolator okay? Let's see if we have, what kind of reading we got on there. 1.8, that's kind of normal. 1.2 is very normal. 1.8, 1, yeah, I think that's normal. So another thing that can go wrong is this control IC that does the switching doesn't get a power supply, and that's because maybe there's an issue with a voltage divider off the main cap, or it could be a Zener. Which one's negative? That side's negative. Where is our rectifier diode? Let's just check that on the output. So we have a twin diode package on the output here. It looks like a transistor bolted to the heatsink, but it is, each outer pin is an anode and the center pin is a cathode. So we go from there to there and we see 0.3 volt drop, so that's okay because they're in parallel. There's a funny little transistor there. Looks okay. Well, I'm going to have to turn this on, I think. Next step is to plug it in and take a voltage measurement on the IC and see, do we have our supply voltage to the IC? There is a diode there. I better check that. In fact, there's 2 diodes there. There's that capacitor, which is probably our cap for the supply rail to that chip, and that diode there is probably rectifying that to that capacitor. So I'm going to measure there. I think that's our diode there. There to there. That's half a volt. That's good. There was another diode kicking around up here. Is it that? Yes, it is. Ah, so that diode's okay. So if this thing was switching, it would become self-running and generate its own voltage rail. So now all we have to do is plug it in and take a measurement while we're plugged in. Unless there's something dodgy with this wiring that wasn't getting out there. I need to isolate this, so I'm going to stick that back in there on its case just to keep it from touching any metal and such, and just be careful of the heat sinks. They could be live when you're doing your measurements. In fact, can I lie that down? There we go, that's better. You know, the easiest way would just be to get another whole one of these, because I bet they're cheap as, and fit it in. And we'll plug it in. Volts DC. Our negative is this pin here on the main filter cap, and our positive is here. We should have 320 odd volts, which we do. I'm just going to double check the output. I'm sure there's nothing on there, and there's not. And if I go from negative to somewhere over this side, there's 8.5 volts. Is that enough for this IC to run? Oh, there's 1.7 on our feedback opto isolator. I wonder if 8 volts is enough for this thing to run. There's the data sheet on our switching IC. If you want to look it up, it's a UC3843. According to the data sheet, minimum supply voltage is 12 volts, so our 8 volts is not going to cut it. It goes from the main filter cap through a 240 k ohm resistor into the capacitor, which I think is used to get it started, and then there's a winding off the transformer that supplies through a diode back to that cap the running requirements. And I'm guessing that because it's only reaching 8 volts, there's something wrong there. And what about the capacitor? It is known in switching supplies that the capacitor on the supply line to the switching IC can go bad and cause this sort of thing. There's no Zener on there, which is interesting. Most things have a Zener, but I guess these were built cheaply. Let's take the capacitor out and test it, because if it's bad, it could be loading that what should be 12 volts down to 8 volts, because 240k is quite a high resistance, so it wouldn't take much to pull that down below what it should be. This is exactly what I'm talking about. VCC pin R start. Okay, so right off our main filter cap, there we are, 300 odd volts through R start, which is our 240k ohm resistor. There's a capacitor, CVCC, and that is enough to get this started. And then once this is switching through the transformer, we have that diode there which rectifies a much stronger supply rail to keep it self-running. Now that diode is one of the ones I tested before, so that's good. We are pulling out this capacitor, a little electrolytic. If I'm going to guess, it's going to be 50 volts and less than 10 micro, about 1 microfarad, aren't they normally? I think, I don't know, could be wrong. But well, let's have a look. I'm trying my hand at manual focus from what I can see on the screen, so I can get a quick start straight into the recording without waiting for the autofocus to catch up, because I usually have to end up editing that out, and the less work I can do in editing, the better. Now let's see, can I grab hold of that and pull it out while it's liquid? Maybe. Here's the prize, and it's rated at 22 mic 50 volt. There you go, it's a little bit beefier. Let's test it. What does Optimus Prime have to say today? 27 microfarad at 20 ohms. Ooh, 20 ohms is is it good? No, my chart says otherwise. Should be no more than about 3 So we will replace that and see if it makes all the difference. I don't think I've ever showed you guys my kit of bits. I've got one for caps, one for resistors, one for diodes, LEDs, one for all sorts. But I've also started making a collection in wall mounted drawers because there's just so many parts to have. Now let me have a poke. What have we got in the way of a 22 mic? It's a bit big. 2.2. There's a 2.2. Do I have like a 33? I'm going to go too big. 33 at 25. That's one mic. 50. I suppose there's a reason they put one like that in. What have we got there? Ah, here we go. 10 mic 50. We'll put that in. Probably should have left them long in case I have to reuse it. Maybe this doesn't work. Have faith. It'll work. Let's just soak up some of that flux. Check for any solder bridges. We're all good. We're all good. That's all good. Just make sure we didn't wick up any solder from the neighbouring parts. They still look attached. And on. Ha! It did it. There you go. Simple. Oh, well, that's good. And it is honestly quite a common problem with switch mode power supplies, is the supply rail to the control IC in the power supply itself. Oh well, let's do a voltage measurement, make sure that it isn't struggling under load and those caps are okay. We need to re-insulate these too. We have 12 volts. No worries. It's not even fluctuating as the lights come on and off. Alright, let's put it back together. Glued back together. Now we just need to shrink around our joins here. So we will put some actual heat shrink on there. Load up with a bit more solder. But what about the other bit you were saying that you pulled the tape off from? Well, I'm not wasting another bit of heat shrink. I totally forgot about it, so I've just wrapped some tape around there again. Should be right. And we'll tuck the wires back in. Where are they going to sit? How about down there? Making sure there's nothing in the way of our screw holes that will get pinched or what have you when we put the screws back in. And how about one last time for the fun of it? Woohoo! What are we on? 14. Now these are showing up a bit different than the other one, I think. Or I'm just dreaming. Do they all work? Yeah, they all seem to work. Oh no, we've got some out. Whoa, okay. That could be for another video. Look, we're missing some LEDs there. Oh, what buttons am I pushing? I'm all over the place. Off. Okay. Yeah. Let's just, oh, you could probably see that. It's not too bright, is it? Let me just maybe take the edge off. There we go. So we have, can you see all of that? So as you can see, we've actually got a few out everywhere. Why is it doing that? No, it's not on the thing. Okay, red. Green. We've actually got a lot of green out. Blue. We've got a few blue out as well. Oh, it's no good. Okay. I'm pretty sure it's not trying to spell something. It kind of looks like oddball alien letters. Anyway. Okay. Well, fault fixed. Kinda. We now have some dead LEDs. We'll ask him if he wants to replace those. Other than that, we got it working again. So thanks for watching another one, and yeah, do we have a different fault in the third one, or will it be one of these two faults that we've had so far? Stay tuned.